Hello everyone. Let us start with another example of a section of solids. Here is the question. Hexagonal prism side of base 30 mm and height 60 mm. It's standing upright with base on HP. So it is standing upright with base on HP. One side of the base and axis are parallel to VP, and one of the side of the base and axis are parallel to VP. Now it is cut by a section plane making an angle of 60 degree to HP and crossing the axis 10 mm from the top. Draw the sectional top view, front view and true shape of the section, and also draw the sectional left hand side view of the object. So let us first of all draw the top view, the front view and the left hand side view of the object. Then we will take the section, and then we will draw the sectional top view, sectional side view and true shape of the section. So first of all, draw the draw the top view, front view and side view of the hexagon. So hexagonal prism side of base 30 mm. So the side of the base is 30 mm and height 60 mm. So height of the prism is 60 mm. Is standing upright with base, one of the base, the base on HP, and one side of the base and axis are parallel to VP. So one side of the base and axis are parallel to the vertical plane. So let us complete this front view and top view. So we have to take one of the side parallel to the XY line in the drawing, because if we will take one side parallel to the XY line, it will be parallel to the vertical plane, and axis will be perpendicular to HP and parallel to VP. So these are the axes which are perpendicular to XY line, that is perpendicular to HP and parallel to VP. So first of all, complete the top view of the prism. It is hexagon. Project the points starting from this corner: A, B, C, D, E, F, P, Q, R, S, T. So A, B, C, D will be the base and P, Q, R, S, T will be the top face. Project A, B, F, C, E and D. Draw the base, measure the axis height of the prism, which is 60 mm, and draw the top face, that is P, Q, R, S, T, U. Now draw the side view, projecting the edge of the prism from the top view, that is E, F, T, U. So E, F and T, U. DS, AP, so A and D and PS, and PQ and CR. So here will be P and C, and here will be Q and R. Height will be projected from the front view. So this will be the top view, front view and left hand side view of the object. As we have following the first angle projection method, top view will be below the XY line, front view will be above the XY line, and left hand side view will be in the right hand side of the front view. Now we have to take the section of the prism. Here it is given that it is cut by a section plane making an angle of 60 degree to HP. Here the cutting plane is inclined at an angle of 60 degree to HP. So the cutting plane makes an angle with horizontal plane. That means we can say that this cutting plane is auxiliary inclined plane, and if we have auxiliary inclined plane, we have to show the cutting plane in the elevation. So auxiliary inclined plane inclined at an angle of 60 degree to HP and crossing the axis 10 mm from the top. So measure 10 mm from the top, it will cross the axis over here, or passing from here 10 mm from the top. So show the cutting plane over here inclined at an angle of 60 degrees. So first of all, measure 60 degree angle this point. So 60 degree, and show the cutting plane. Passing from this point and this point, show the cutting plane. We have to darken the end of the line because we are showing the cutting plane line. Now let us draw the section top view section side and two shape of the section. So first of all, mark the intersection point of the cutting plane to the prism. So here will be the first point at the base, 1 dash. Here is the second point to the side edge, 2 dash. Here is the third point, 3 dash on the top face, or we can say that there are two base edge or top face edge over here. One is RQ and second is TU. So RT and QU. So we will mark one another point, 4 dash, as we can say that if 3 is on RQ, then 3 is on RQ, then 4 is on TQ. Here also, here there are two side edges. One is ET and second is CR. So one is ET and second is CR. So here will be the fifth point, 6 dash, and here will be sixth point, 6 dash, because over here there are also two base edge. So one is DE and second is CD. So CD and DE. So 6.1. If one will be on CD, then 6 will be on DE. Now project these points to draw the section in the top view, 1 and 6. So one will be on, if one will be on CD, then 6 will be over here on DE. Then 5 will be 2 will be over here, and 5 will be over here at E, and 2 will be here. We will mark after 2 more points. So these are the intersection points, 1, 2, 3, 4, and these 2 points. So this is 1, 2, 3, 4, 5 and 6. Connect this part to show the section in the top view. How show the section? Let us make it with color that we can see the section part in the top view. So this will be the section in the top view. Now draw the hatching line or show the hatching line in the top view. So this will be the section in the top view, and now we can say that we are going to remove this part. So we have to show this part as a light outline, and we are going to show the section in the top view, and this part will remain as it is. So we have to draw this part with dark outline. Here also we are going to remove this part, though that part should be over here only. So it should be by the light outline, and this should be by the dark outline. Now let us draw the section in the side view. So 3 and 4 will be over here at this point and this point. 2 and 5, 2 is on the side edge CR. So here will be 2 CR, and here will be 5, and we have to project this 1 and 6 from the top view because it is cut at the base edge. Project 6 and 1. Rotate it. So this will be the first point, 1 double dash. Here will be 2 double dash, which we have projected from the front view, and 3, 4 will be at the top. 2 double dash. Here will be 3 double dash. Here will be 4 double dash, 5 double dash, and 6 double dash. Now join this part. to show this section, the side view. So this will be the sectional side view. Now show the hatching line in the side view. So this will be the section in the side view. Now let us draw the true shape of the section, and to draw the true shape of the section, first of all draw a reference line parallel to the cutting plane. So this will be a reference line which is parallel to the cutting plane, x to y2. Project these points perpendicular to x to y2 line. That is, this is the projection of 1 6 2 5 and 4 3 perpendicular to the x to y2 line. Now measure the top view of the section from the intersection point of the projector to the xy reference line. So this will be the measurement of 1. So measure 1, given I'm from x to y2 line, this will be 1. Also measure 6 from the intersection point of this projector to the xy line. So this will be 6, 1 6. After 2, 5 from here. So this will be 5. 4 is also at same distance, so 4 and 3. Join these points and draw the true shape of the section. So this will be 1 2 3 4 5 6. Join these points and now draw the hatching line in this part. True shape of this section. Hatching line should be inclined at an angle of 45 degree to x to y2 line and complete the true shape of the section. So this will be the true shape of the sectional top view and sectional left hand side view of the object. So make sure that the cutting plane is inclined at an angle of 60 degree. Here it is given. Okay, now let us do another example. A cylinder 50 mm diameter and height 60 mm is resting on HP on its base. So again the base is on HP. It is cut by AVP. Here it is directly given that it is cut by AVP. So auxiliary vertical plane, it is a plane which is perpendicular to HP and inclined to VP. So the auxiliary vertical plane is perpendicular to HP and inclined to VP by 45 degree and cutting it remaining 12 mm away from the axis. Draw the projection with section and also the true shape of the section. So we have to draw the top view of this, we will draw the front view of the section because section is going to generate in the front view because we are taking the auxiliary vertical plane, and if we have auxiliary plane cutting plane, we have to cut the object through the plan. So now first of all draw the front view and top view of the cylinder. So this will be the top view of the cylinder. The diameter of the circle is 55 mm, base circle diameter 55 mm. Draw the base. Here I have shown only 4 division. A, B, C, D is the base and P, Q, R, S is the top face. Now project A, B, D and C. This will be the base. And now measure the axis height, which is 60 mm. And draw the top face, P dash, Q dash, R dash, H dash. So this will be the front view and top view of the object or of the cylinder. Now let us show the cutting plane. So it is cut by AVP. So if AVP, we have to show the AVP in the plan perpendicular to HP, inclined at 45 degree. AVP inclination 45 degree and cutting it remaining 12 mm away from the axis. So we have to show the cutting plane in the plan. So here will be the axis and plan of the axis and should remains 12 mm away from the axis. So first of all, what we have to do, first of all, measure an angle of 45 degree from the top view of the axis, that is the center of the circle. 45 degree angle. Draw this line. Now draw a line perpendicular to this line. So let us say that 90 degree line from this line from the center. So draw a line perpendicular to this line from the center. The angle of this line is 45 degree. Now measure 12 mm distance on this perpendicular line. So 12 mm. Now our cutting plane will pass from this point 12 mm away from the axis. This will be the plan of the axis. So now show the cutting plane, which is inclined at an angle of 45 degree. So this is 45 degree angle, and if we will draw a line parallel to this line, the angle of that particular line will also 45 degree. So from this point, which is 12 mm away from the center, show the cutting plane over here. We have to dark the ends, because to draw the or to show the cutting plane line, we have to use the line thick at ends and thin elsewhere. And we can also say that it is a cutting plane line. Now this angle will be 45 degree. So the inclination of the cutting plane is 45 degree, and it is 12 mm away from the axis. So this distance is 12 mm. So now this should be cutting plane. Now mark the points of intersection of the cutting plane to the cylinder. So this will be the first point, and it is cutting like this, so it will cut the top face and base also. So we have to mark 2 points at each intersection. So this is 1, this will be 2 and 3. So 1, 2 on the top face, and 3, 4 will be on the base. 1, 2 on the top face, and 3, 4 will be on the base. Now project these points, the elevation. So if this point is 1, this is 4. If 1, 2 on the top face, then 1 over here, 4 on the base, and 2, 3. So 3 on the base and 2 on the top face, as we have discussed. So this will be 1 double dash, 2 double dash, 3 double dash, sorry, only dash, because double dash is used to show the side view. And this is 4 dash. Now join this part and show the section in the front view. So this will be the section in the front view, and to observe the section in the front view, and the observer will be over here. So we have to remove this part. So here we have shown this part with light outline, and this part with visible outline or dark outline. So this part is going to remain as this part is going to be removed. So in the elevation also, we have to show the removed part by the light line and the remaining part by the dark line. So this part is going to remain, and this part is going to be removed. Now show the hatching line. In the elevation, it will be the section in the front view. So this is the sectional front view. Now if you want to draw the true shape of the section, because it is here, it is also given to draw the true shape of the section. If you want to draw the true shape of the section, we have to draw a line parallel to the cutting plane line. This is our x2 y2 line, and this is our XY line. So now to draw the section or two shape of the section, you have to measure the section from the XY line. So or the projection of the section or point of intersection of the projection of the section to XY line. So we have to measure the section from XY line. So here will be 1. So 1 over here. So this point will be 1, and point 2 will also remain as it's at same distance. So this will be 2, 3 and 4 will remain on XY line. So here it will remain on X2 Y2 line. So project these points perpendicular to the X2 Y2 line and complete the section. So this will be 3, 4, because here 3 and 4 is on XY line. So here it will remain on X2 Y2 line, and here will be 1 and 2. Now connect this part, that is 1, 2, 3, 4. So the section, true shape of the section will be a rectangle. Now show the hatching line in this part, and hatching line should be inclined at an angle of 45 degree to the X2 Y2 line. Okay, so this will be the true shape of this section. So this is it for today. Thank you.